Hi, I'm Dr. Tim Komar, and in this video, we will show a couple examples of calculating derivatives of functions using the chain rule along with the product and quotient rules. So for a quick reminder of the chain rule, let f and g be differentiable functions, then the derivative of a composition of f composed with g is simply f prime composed with g of x times g prime of x. Or if we want to write it in a simpler form, if that's going to help you think through some of these examples over here, if u is just another name for that function g of x over here, the derivative of f composed with u is f prime of u times u prime. And a quick reminder of the product and quotient rules here. So if u and v are differentiable functions, the derivative of the product u times v is u prime v plus uv prime. And the quotient rule, similarly, u and v are differentiable functions, and we got to make sure that the denominator is not going to be 0 here. Then the derivative of the quotient of u and v is u prime v minus uv prime divided by v squared. The first example we're going to look at is the following. We're going to compute the derivative of this function f here, which is x to the fifth plus 4 cosine x over x squared plus 1, all raised to the third. So in this particular example, our outermost function here is that cubing function over here. And then there's a quotient inside that cubing function. So the way we're going to approach this is we're first going to use the chain rule, and then the derivative of this inside part here will require a quotient rule. Let's see how it looks. So our first step here, and I'm going to put in green here our outermost function. The derivative of that outermost function stuff cubed is going to be 3 times that stuff squared, then times the derivative of that stuff. And that stuff is the quotient over here. And notice this first step, I've just left this remaining to derivative to calculate with the prime symbol over here. So we're kind of leaving it for the next step, and we can take things one at a time over here. Now, on the remaining part over here, we need to compute the derivative of x to the fifth plus 4 cosine x over x squared plus 1. And here is our color-coded quotient rule here. So again, we have the derivative of the numerator function, x to the fifth plus 4 cosine x, times the denominator function, x squared plus 1, minus the numerator function again, x to the fifth plus 4 cosine x, times the derivative of x squared plus 1, all over that denominator, squared, x squared plus 1 squared here. And as I did in the previous step, those two remaining two derivatives to calculate, I first just wrote out the rule formally and can then compute the derivatives in the next step over here. So the derivative of x to the fifth plus 4 cosine x is 5x to the fourth minus 4 sine x, and the derivative of the x squared plus 1 is just 2x over here. And in a colorful fashion over here, we have our derivative of our function. And one quick review on this again, we took things one step at a time. We worked from the outside inward, and we used one differentiation rule at a time. Next example. So here, we're going to need to use the chain rule, but first, we're going to need the product rule here. So here our function f is defined as the square root of x to the fourth plus 1, then times e to the x over here. So we clearly see a product of this square root times this exponential function over here. But each of these two factors here will require the chain rule to compute the derivative. So we're going to take things step by step here again. So we're going to start out with the product rule here. So we're going to need the derivative of the first factor, which is the square root of x to the fourth plus 1. then times e to the 3x, and then plus that first factor, square root of x to the 4th plus 1, times the derivative of the second factor, e to the 3x over here. And notice on this second line over here, I put the outside functions of the compositions here in green so that we can observe the chain rule on the next step over here. So if we need to compute the derivative of the square root of x to the 4th plus 1, the derivative of the square root function is 1 over 2 times the square root of whatever its inside stuff is, which is that function x to the 4th plus 1, then times the derivative of x to the 4th plus 1. And over here, very simply, the derivative of e to the 3x, again, is e to the 3x times the derivative of 3x over here. So our final step in our calculation, we need to calculate these remaining derivatives here. The derivative of x to the 4th plus 1 is just 4x cubed, and the derivative of 3x is just 3 over here. And I've just rearranged things and rewritten it all not so colorfully over here, and we're going to leave it in that particular form. So the difference between this example and the last example is the first example required the chain rule first. This example required the product rule first, and then we had two little applications of the chain rule illustrated here in green. Again, I'm Tim Komar. I'm available for mathematics tutoring for all high school and college mathematics courses. Please like this video, watch some of the other videos, and contact me for tutoring. Hope to see you soon. Take care.